Okay, chemistry people, this is my on-level and pre-AP chemistry notes, dimensional analysis continued. So I'm working example number 4 in the notes. So I worked the first 3 already in my previous videos. So this one says, how many moles of ammonia are there in 338 grams? So again, we're always going to list our given, list what we're looking for, and we start with our given every time. So my given is the 338 grams in the problem. It's the only number told to me. It's my only information. So that is my given. You can have more than one given in a problem. In this case right now, we're starting really simple with just one given. And what we're looking for is in the question. It says how many moles. I am looking for moles. It's asking me to solve for moles. So I'm always going to start with my given. In this case, there's only one, so I don't have to choose, and it's just going to be 338 grams, and I'm going to put it over 1. This does not change the number at all. It just shows me where my units are at. So this is all the information so far from the problem. So now I need to figure out how to convert from grams to moles, and so I can do that by molar mass. That's what connects grams and moles. So first I need to solve the molar mass of ammonia. So I'm going to start by listing the elements, which is just nitrogen and hydrogen. List how many I have of each, which would be 1 and 3. Multiply them by their masses found on the periodic table, which would be 14.007 and 1.008. So then I'm getting roughly 17.03. 17.03 grams. So you should get something close to that. I did that memorizing those molar masses. So if nitrogen's slightly wrong, should be 14 point something. It's either 007 or 14.07. So then I have that is my molar mass, which means if I had 1 mole of ammonia, I would have 17 grams of it. I don't necessarily have 1 mole. I'm trying to figure out how many moles I have. But remember, I'm going to set up that fraction. Either 1 mole is going to go on top, and 17 grams are going to go on bottom because this is just 1. It's the same thing. Or I'm going to have 17 on top and 1 mole on bottom. How do I know which one to use? I use the one that's going to cancel out my units. I have grams up here. I want to cancel out grams and convert to moles. So I want grams to go on bottom and I want moles to go on top because that's what I'm solving for. So I'm going to pick the one that has grams on bottom and moles on top. So 1 mole of ammonia is equal to 17.03 grams of ammonia. So when I do that, my units can cancel, and I'm left with just moles of ammonia, which that means I'm going to take 338 grams, and I'm dividing it by 17.03 to get the moles. So whenever you do that in your calculator, you should get the answer to be 338 divided by 17.03. I'm getting it to be 19.8 grams. 19.8 moles is your answer. So if I had that many grams of ammonia, I would have 19.8 moles of ammonia. So that's how you work that example problem. In the next video, I'm going to work out the next example problem. It is a 2-step example problem. All these other ones, we've been going from moles to molecules, from molecules to moles, which they are connected by Avogadro's number, or we're going from moles to grams or grams to moles, which those are connected by molar mass. The next video, we're going to go from molecules to grams, which means I need Avogadro's number and I need molar mass. I can also go from grams to molecules. Again, I still need molar mass and Avogadro's number. So it's going to be a 2-step problem in the next video. So this one's harder. So you may need to replay the video a few times. I'll try to break it down and explain it as best I can.